Yeah, welcome to this podcast. I have with me Abhishek Singh. He has a BE Eco honors from Shriram College of Commerce, and he was working at ISB for a period of 1 year after that. And then he decided to go for MSc Economics from Madras School of Economics. And after that, he has worked at two consulting companies. Right now, he's working at KPMG, where he analyzes the financial risk of banks, as they decide to lend. Prior to that, he was working at ACIC Consulting in Bombay. But his current role, the one where he is absorbed now, is primarily concerned with data that financial institution uses. Yeah, welcome to this podcast, Abhishek.
Hi, Manan. It's a pleasure to be interacting with you.
Yeah, thank you for agreeing to do this and bringing your knowledge and experience, whatever that you have acquired. And yes, I'm actually looking forward to this discussion because it's about financial institutions and how they use data. Yes, yes, Abhishek. So could you tell what kind of data science technique that you are absorbed in your role currently as
Yeah,
you analyze the financial risk of banks, Abhishek?
yeah. So, right before starting, I would like to state that the views I express in this are purely my views and not the views of my employer. So, anything stated is my view, my personal opinion.
Yeah.
Now, coming to the kind of work I do, I majorly work with financial institutions and help them in analyzing their credit decisions and helping them with submitting several regulatory reports or regulatory reports or models that are regulatory in nature in order to come up with their credit risk calculation. So every bank needs to have a certain amount of capital allocated for different purposes. So that's
Yes.
known as the capital adequacy ratio. So the
Yes.
capital adequacy ratio is capital hold divided by our risk-weighted assets. So
Yes.
these risk-weighted assets can be uh, risk-weighted on the basis of credit, market, or operational risk. So basically, for coming up with your risk-weighted assets on the basis of credit risk, there are a set of models used. And secondly, also for coming up with your provisioning requirements. So the Financial Reporting Standard 9, International Financial Reporting Standard 9 states that you need to proactively provision for your credit loss in the future. So this is known as expected credit loss. So
Okay.
there are a set of models primarily used to calculate your probability of default. There are three components when you come up with your provision. One is your probability of default,
Okay.
second is your loss given default, and third is your exposures. So usually
The
what
third
we
is
have
your
seen in exposures. So how much
exposure.
outstanding amount is there? So for example, a bank has lent to me. I am Abhishek. My exposure to the bank will be 1,000 rupees. I'll have a certain probability of default,
Okay.
say 2%, and
Okay.
then loss given default. Given if it's an unsecured loan, we can say that I have a loss given default of 45% or 75% based on the kind of debt the bank has lent to me and also on the type of exposure it is. But usually the loss given default and exposures, they are not driven by models in India. It's usually the probability of default that is driven by a model. So probability of default is calculated using historical factors. So for example, behavioral factors can be one, that how is my what buckets am I operating in. Suppose, so by buckets I mean like there might be a person who is not paid his loan for a duration of 0 to 15 days, 15 to 30 days, 30 to 60 days. So according to which bucket he's transitioning, suppose he is transitioning from the 15 to 30-day bucket to the 30 to 60-day bucket, then that means there's a higher probability that this customer will default. So this can be one behavioral factor. Second, there can be external credit scores. So according to your ability to pay to external borrowers apart from the bank that we are, external credit bureau data will give you information about whether he's paying other payments that he's obliged to pay. So if he's not paying them, there is a chance that he might default on commitments with the bank that we are consulting with also. So even that will spike up your probability of default. So yeah, and apart from that, there might be some behavior, like these are very traditional behavioral factors. There can also be non-traditional factors that can be used on the basis of data availability, like am I paying my utility bills? Is there any court case against me which has come up, some legal factor? So in case the model has this data available, it will account for this and obviously eventually lead to a spike in the probability of default, and accordingly I can provision. So this provision is proactive in nature, and we can the expected credit loss will be. So what basically happens is that while calculating expected credit loss, we categorize the customer into stages. So in case these are primarily 3 stages. In case the customer has not defaulted, or he's defaulted only for the past 30 days, then it's a stage 1. But so here the provision is pretty limited. We just take the probability of default and multiply it with the exposure and loss given default. But now if he comes to stage 2, so now if it's purely on the basis of days past due, so if I not paying for more than 30 days, so on the basis of that, what will happen is now the bank will be more proactive in nature. So it won't take my probability of default only for this time period. It will also consider my probability of not paying the loan due amount in future time periods. So for example, I'm not paying 1,000 today, but it will also consider other probabilities of not paying 900 tomorrow, 800 after 3 days. So the entire life cycle of that loan, I will consider the entire life cycle in that case, so that the provision spikes up there, because the entire life cycle I'm considering the loan not to be like different probabilities in the entire life cycle. So
I'm assuming this will be like a big data set, these banks are maintaining of all the customers, right?
So Indian banks usually we can get 5 years of data, but if you are dealing with a foreign bank, then you obviously have a large data sets which cover even periods of recession. So those are very like if I'm going to a period of a recession, like a 2007 recession, the great financial crisis, there I'll also get to know about the losses taken might be higher there, right? Because the ability to pay of people is not high. So that is like if I get it through different life cycles, then obviously the model might be more accurate in coming up with the expected credit loss, and it will also be more conservative in nature.
But whatever data that you have, and based on the data, you come to your conclusions. The point now that I want to focus on is what techniques that you use to come to conclusions. For I think you focus a lot on this ensemble method, right? Which is building decision trees, and there are like 2 components of ensemble method. One is bagging, the other is boosting. But for the purpose of this discussion, we are purely focusing on bagging. So could you tell in finer details, Abhishek, the ensemble method and then bagging?
Yeah. So firstly, I'll say tell in my job, like I was telling you about the probability of default. So to come to a conclusion about the probability of default, I need to know whether the person is defaulting or not. That's the decision, right? So I
Yes.
come to that decision on the basis of a set of features. So the features can be about his ability to pay, his credit score, his past due behavior in my bank, or his past due behavior on external credit bureaus.
Okay.
So so there are a set of methods that we use to come at. It can be something as simple as a linear regression or a logistic regression. So which is on the basis of 0-1 logistic regression.
I was
But now
thinking that
nowadays,
logistic regression would be more suitable here because it's like, binary,
yeah,
whether you
obviously
lend or
it's a
not.
0-1 decision. So
Yes.
it'll be a logistic regression to come up with that. So logistic regression, the only disadvantage is that it is linear in nature, and a lot of times what we observe is that the data is non-parametric. So it's not necessary that just because a feature is spiking up in one direction,
Yes.
the default probability should go up. So for example, a very simple example I can give you. So for example, there is a person who has gone into the DPD 90 bucket. That means he's defaulted in the past 6 months.
Okay.
But now this person has, after defaulting, he's come back as a refreshed borrower. Maybe his loan was restructured or he paid back the loan after the time of duress. So
Okay.
ideally, if I was having a linear model, the model would say that the probability of default of this customer will be pretty high. Because he had gone into the DPD 90 bucket in 6 months. But this might not be the case, right? Because just he has defaulted and the loan's been restructured and he's out of duress. It might even be the opposite case, right? That he might not default at least in the next 6 months.
Okay.
Because DPD 90 was one instance, and there's no other instance of 30 days past due and 60
Yes.
days past due. So then in this case, there are these non-parametric models, which are on the basis of statistics,
Yes.
statistical information purely, they work better. So they might be more complex in nature. So the interpretation of this causation factors, the interpretation wise, they might not be as, we might not be able to explain the impact of independent features on the final decision as well as a linear regression. But at the same time, in terms of coming at an outcome, they might be more accurate. So that is when we come to these decision trees is the base, foundational base of all, like most of your ensemble learning methods. So, so coming up to decision trees, so I can give you an example of decision tree in classification.
So that is what I was saying. Decision trees, you have first is classification and then you have regression, right?
Yeah.
So could you, Abhishek, give an example of classification in decision trees?
Yeah, so classification, I can use my same example of whether a borrower defaults or not. So to come up with that outcome of whether he defaults or not, I can use a set of decisions. So the decision might be if his credit score is greater than 600, the chance of him defaulting is not there. Chance of default is not there. But if his credit score is less than 600, I can ask a sequential set of questions. Has he defaulted in some loans by other borrowers or not? If he is not defaulted, then it might be lower his chance of default. Whereas if he has defaulted, we can assign him to a default category. So these are a set of decisions which are used to come at an outcome in a decision tree. So this is how I can classify them. So what my major aim here is the features that are used. So the first feature I told you about was the credit score. The second feature was his standing in the overdue market, like in the external market. So these features need to be such that they separate your data points to the maximum. So they need to be such that once they separate the data, the final data set that is made is within itself, it should be homogeneous, but it should be very different from the second data set in terms of the outcome. So that will ensure maximum separation. So whichever feature has the maximum separation, so whichever features allows for maximum separation, that should be at the top of the node, the root node, which is known as. And then on the basis of that, you can divide. So my root node can be the consumer score there, CIBIL score. Then on the basis of that, there can be other questions asked. So this is an example in classification. Now coming towards regression.
Yes.
So for example, regression question could be, what is the price of this house? So price of real estate. So the price of real estate also, there is a set of features, right? That need to be used to come at the price of real estate. So for example, my first feature could be, what is the city? Because the city is a primary determinant of real estate prices, right? So I think that will cause the most heterogeneity across the classes and homogeneity within the class. So maybe Hyderabad, this land costs 1 lakh rupees, whereas Mumbai, the same piece of land costs 4 lakh rupees. Okay. Now, on the basis of that, we can also ask whether this is situated in urban Hyderabad or semi-urban Hyderabad or on the outskirts of Hyderabad, right?
Okay.
And then we can further separate it. Then there could be other questions that could be asked, like, are there schools located close to this property?
So these questions, Abhishek, for the sake of clarity, these questions are being addressed to the client who wants to, buy the house, correct?
No, these questions are basically like, end of the day, they are a part of the data set, right? The features. These questions are nothing but features. So these features are derived, like, you can also do it on the basis of client suggestion, but ideally it should be on the basis of quantitative data historically, which is present. Okay. So that will ensure that your model is scientifically driven. Because if I'm doing it on the basis of client, it's more of a qualitative discussion.
Yes. Okay.
That he says that this is how it is. But if I have a set of data saying that in Hyderabad, properties near schools, they cost more than properties which are not near schools. Because so I have a considerable set of data, large number of data points. So
for example,
when you're separating also,
which is like the hub of all the the MNCs, right? So that factor also goes in there, right?
Whether that can also be a factor. So there need to be a considerable set of decision like data points to come up. So when you're splitting these decisions, there can be a chance of overfitting. Okay, that would happen when maybe there are only 2 data points. Suppose one school, one property is opposite a club, the other is not opposite a club. But just because of this data point, just because of these 2 data points, if you split it, this is not necessarily, it's not necessary that this will work on some other data, right? So you need to be careful while splitting that you have a considerable amount of data points. That feature should have a considerable amount of data points. So for example, we were working with a client where they were telling us that if the borrowers have gold loans, there is a possibility that they are able to default less because they might be richer having gold loans. But our point was that the amount of data points that we have is limited and this could go either way. So it did not make sense to explore this feature because it would just cause more confusion in the data set. And so we did not go ahead with taking this feature into consideration in the decision tree. So we need to be careful about what kind of features we take in the final decision tree. So some features, just because you see it in 2-3 factors, you don't use it to split the data. So it needs to be present in a significant amount of observations. And so that once it's present in these significant amount of observations, we can we can use it on outside external data also, which has not been trained on this, right? So that is where the accuracy will increase of this model.
In terms of the real estate, so one is that what you are saying is that you take into consideration all the external factors, like where the house is located, proximity to, for example, school, colleges, right, hospitals. And whether it's like downtown, let's say middle of Hyderabad or middle of Bangalore. But what can also be a factor is, let's say, the number of bathrooms, the number of bedrooms.
They could be a factor, definitely. Obviously, the number of Yeah, they could be in fact a more determining factor.
Yeah,
So
this-
yeah, that's what you'll have to go sequentially in the process.
Okay. For example, let's say it can also be based on the reputation of the construction, company. So that also
Yeah,
plays a part, right?
yeah, yeah. So that's what I was saying, that you need to be careful about what feature you're going for. If the feature has adequate data around it, adequate number of data points, then you can split it. But if I have just like 5-6 data points which are on the fence and 5-6 on the other side, then I don't think it makes sense always to
because you
go.
run the risk
But if you have like
what is known
overfitting,
as overfitting or underfitting, which is bias in the specification, right?
yeah,
This
correct.
specification bias. So okay, so this is one thing. And Abhishek, this bagging, can you give some input on that?
Yeah.
Next 5
So
minutes.
now, what is an ensemble learning method? There are a combination of different models, right?
Yes.
So when we come to ensemble learning methods, we have different kinds of methods, bagging and boosting, as you had earlier mentioned.
Yes.
So with the respect to bagging, it's nothing but two things that are done. One is bootstrapping and second is aggregation. So
Yes.
bootstrapping is when we, suppose I have 10 data points with me. I use like 6 of these data points for training, but the trained data points, I randomly replace them. Okay. So suppose first time I select, suppose these data points are A, B, C, D, E, F. Okay.
Yes.
So the first time my selection is A, B, C, C,
Yes.
D, D. Okay.
Yes.
Those are the 6 data points. Second time when I select, it can be A, B, D, E, C, C again. Okay.
Yes.
So like that, I'll come up with different bags. Okay. So this is the first step of the process, where I'm coming up with bootstrap bags with replacement. Okay.
Okay.
So once I come up with these bags, using the data points, I'll come to a decision. So the decision that I come to, I take an aggregation of that decision, and this is what a random forest is. So the forest is nothing but the different kinds of decision trees. Okay, so
basically
it's not
what you are
necessary
doing
that
is to reduce the variance of the decision tree, right? Because you're
correct.
segregating the right.
Yeah. So the decision tree here, so there might be 5 features that I have. So every time in every model, every decision tree, because random forest is a combination of decision trees. So every decision tree might not use all the 5 set of features. I might use 3 features sometimes, 2 features sometimes, but on the same bootstrap data set. And this will finally I'll come to a decision, right? So using that, whatever the decision is, the aggregation of that, the end aggregation of that would lead to an outcome. So that is how I'll come with an outcome, a mean of whatever the. So it is not necessary. Even if I have
that is known as weak learners, right? Because
so there might be some weak learners here which are not predicting, right? But because I have so many different decision trees, it is highly possible that these decision trees will outweigh the weak decision trees. So or the decisions from these the outcomes from these decision trees will greatly outweigh the outcomes from the wrongly structured decision trees. So finally, whatever voting through voting mechanism, whatever final result I come up with will be nothing but a mean of the decisions. And suppose there are 9 yeses and 1 no, then I'll go ahead with the yes with whatever decision. So that is how a random forest, which is a type of bagging ensemble technique, works. So it is nothing but a combination of decision trees. Obviously, like you can read up more about this on YouTube. There are a lot of resources.
Yes. So just can you give one example, Abhishek, a quick one, like where exactly this is used? Bagging.
What random forest or
the bagging, bootstrapping, and aggregation.
Yeah, so so exactly, random forest, they can be used for regression modeling or classification. But like in classification, they are used in credit appraisal. Like,
Okay.
would I want to
Okay.
give you a loan or not?
Okay.
So on the basis of some historical features, I'll train my random
Yes.
forest on those features, and then I'll evaluate the accuracy of this random forest. So
Okay.
ideally what happens when we are doing any project is that like suppose we have 1,000 data points, we train our data on 600 data points. Okay. Then the 400 data points that are left, we use that for testing the result of the original model. So if the model performs well on the test data, it is a good sign that ideally this model will work. So
Excellent. Got it.
Because it's performing well on data that it has not been trained on, right?
Yes.
So that is how it should
Now
it should work in that case.
Big data is available, so you have actually large data set, running into tens of thousands of data points, right?
So even banks have model monitoring teams who monitor on a regular basis, because once my model is made, there are high chances that over a period of 5-6 years, the economic factors or some factors might change, or the model might not be good enough. And the accuracy of the model keeps coming down. So that is also a major part of the bank, major exercise at banks to evaluate how accurate these models are.
Okay. Great. Excellent, Abhishek, because, you've actually covered the contemporary, toolkit, which is, used in the financial institutions. So it would be grateful, Abhishek, if you could just, give a rough summary, to me in terms of, the kind of things, that you do, Abhishek.
Yeah, so the kinds of things that I do, as I earlier stated.
Because the point of this is actually I could, then include in my module, which is, like a rough sort of a, summary. Okay.
Yeah.
I can make up the data myself. That's not the, the problem. But yeah, it's better to be aware of, what is actually happening on the ground. But yeah, thank you, Abhishek, for giving such a detailed overview of what is being done in these financial institutions. Yeah, thank you, Abhishek.
Thanks, Manoj. It was a pleasure being.
No, it was actually pleasure for me also, to get to know, these technical things. Yeah, thank you, Abhishek, so much. Thank you.
Thanks.
Thank you.